My name is Dana Golden. Thank you for joining us again. Today we're going to be running through an optional intro to R. It's going to be at a very basic level. I want to prepare you for the R homework. If you're interested in R and you want to go a lot further, definitely feel free to look at any of the guides that are available online or on YouTube. I'll try and post some of those as well. If you already have R experience or already some coding experience, maybe just look at the syntax of the file to convert from the other language to the language that we're talking about R, or maybe just ignore this lecture altogether and run away with the assignment. Just today we're going to real quick go through some basic syntax in R. So this is RStudio. I encourage you to download RStudio, and then run the code with me. So here we have the text editor up top, and then down bottom we have the command line interpreter. You can also run it straight from command line, but everyone, I think, realizes this is a very good IDE or integrated development environment. You can also run it in Collab using Jupyter Notebooks. We won't get into that today, but that is an option. So first thing we're going to talk about is variable assignment. So you want to assign a value to a variable, you use this goes to operator, which is a less than followed by a dash. So I encourage you to either have the file open, be running with it, or write the code as I do it in the command line and run it. So right here, we've now assigned the operator, and then now we're going to print, this is message, which is our print statement, value of x, and then we're going to have it print the value of x, which is our variable. Value of x, 5. And then now we're going to assign value of 10 to y. We're going to do z goes to x plus y, and then we're going to sum them together, and then sum of x and y is 15. So these are very basic operations. We're going to keep it very simple and light in this course because it's just an R intro. If this was a more complex class, I expect you to do more. We're not going to do that today. So we're going to create a vector. Numbers is a vector. Vector starts with the C and then parentheses of your elements separated by commas. And then we're going to print it. So we're printing all the numbers, vector of numbers, and then each of the vectors of numbers. If we want to index an element from a vector, we can use this. Brackets of a potential element in the series. One thing you'll notice is that we're asking the first element and we're using a 1. In most languages you'll deal with, languages are indexed from 0. R is kind of unique because it's a data science language, so if you type in numbers of 0, you won't get anything all that useful. But if we assign 1 to numbers, we'll get 1. If in another language like Python, numbers of 0 would have yielded 1 here. Let's see what we get when we do numbers of -1. With numbers of -1, you get everything except the first number. All right. So now logical operations, you can do greater than or equal to, less than or equal to. So let's, we're doing is greater is if x true is going to go to true or false based on if x is greater than y. So x is 5, y is 10. So is this going to evaluate to true or false? What's going to show up on this command line? I'll give you a sec. All right, let's run it. That was the wrong line. There we go. False. Is x greater than y? False. Let's do some basic control structures. So if x is greater than y, we know this is going to value to false. We do x is greater than y, so this is not going to evaluate to true, so it's not going to be, this statement's not going to go through. And so else x is not greater than y. So what should this print? So first off, we're going through an if statement. So if this is true, it's false. So it's going to move on to this else. and then it's going to print this. So let's see what happens. Let's see if that actually happens. Yep, it went through the print statement and it printed the second message. And then now we're for number of numbers. We're going to print number, and then the word number was followed by space, followed by the number. So remember, a for loop does an operation a certain number of times, and as in any other language, you can nest them. And here we go. We print a certain number of numbers. So now we're going to create a function that's going to add two numbers together. It's going to be able to be used in other places to do this. So it adds two numbers together and returns a result. And so now we're going to create a variable called result, which adds the two numbers 3 and 7 together. And so we should get what? When we print this, what should we get? We should get 10. And of course we do. One thing to remember about R, if you know about programming, is that it's case sensitive. So if I type it corrected me there, but if I type result with a capital R, it's not going to let me do that. So result is different from result. It's a very important thing to know if you're working in a language. So now we're going to load the empty cars package as a data frame. A data frame is basically, you can think of it as an Excel spreadsheet. It's a series of vectors, each containing its own data type, and it can be used to do a bunch of different things like numerical operations and regressions. So this is the data set that you're using in your homework. And then we're going to do head. So this will display the first few. Usually 5 is the default rows of a data set. So here we see the first few rows of the data set, and this allows you to get a feel for what's going on in the data set. Here you have multiple gallons, cylinder, displacement between the wheel, gear, and carburetor, just different variables. Then you have structure, which tells you what the types of values of each of the variables is. Here they're all numerical variables, so you might not be able to do linear regressions, for instance, with string variables. You might have to create a factor. We won't talk about that today. Then we get summary statistics. So for every variable, we get the min, first quartile, median, mean, third quartile, and max. And so you can look at them all there. If we want to get the mean of a specific variable, we can do mean. And then here's this $sign operator. This $sign operator allows you to reference a specific variable from a data set. So now we're going to set mean MPG is the mean of MPG from MP cars. And we get 20.09, which is the same value we got here in summary statistics. Now, we talked about Doppler a lot in the lectures, a little bit in the lectures. We talked about Doppler a lot and a little bit in the lectures. So now we're going to use Doppler. Just a reminder, Doppler is from the tidyverse library, and it's a way to manipulate data. So here we're going to select several columns, and we're going to print the head from those columns. So it's just going to present the first few rows of these columns, and there it goes. And now we're going to filter the data. We're going to change it so that now the data is only empty cars if miles per gallon is greater than 20. Before we do this, I'm going to print empty cars right now. Empty cars. So some of them have less than 20, some of them have greater than 20. So we're going to filter it. And notice the head of filtered data is the same, except now instead of 18.7, we have the 22.8. Or is it? Oh, no, it's a. Yeah, we have these 24.4 and 22.8, and then filtered data we see is now smaller than empty cars, but because we haven't adjusted empty cars any, it's still the same length. So filtered data is a subset of empty cars. You can create more complex filtering operations and combine Doppler operations. Now we would like to arrange empty cars in descending order of MPG and then print the head. So now you notice that before MPG goes down and goes up, it's really not arranged in any particular way. I think it's arranged by manufacturer here. Now you start off with a high MPG and go to a low MPG. Now we're going to mutate, which means that we're going to add a new column that is a operation applied to your current columns. So you apply some operation. In this case, we're going to be multiplying it by this number. This number is special significance in cars. Can anyone guess what it is? Obviously, because it's weight kilogram, we're converting from pounds to kilograms. Obviously, we should probably be using kilograms to begin with, but, you know, it's just for fun. So, yeah, now we have a weight, which is right here. Actually, no, this is weight tons. Sorry, this is weight in tons, and then this is weight in kilograms. You're converting from standard tons to kilograms. And then you're calculating the summary statistics again. So you do data summary goes to empty cars. You do this Doppler operator, which allows you to perform this operation on this data set. Mean MPG equals mean of MPG, and then max of HP equals max of HP. So you're able to choose which summary statistics you're getting. And then we get that, and we only get the summary statistics we want, which is very useful because sometimes you don't want to summarize all variables, and sometimes you want to apply only certain summary statistics. So here we're going to group by cylinder, and then we're going to, for each of the cylinders, so for the 6 cylinders, for the 4 cylinders, for the 8 cylinders, we're going to summarize the mean miles per gallon and the count. So before I get started, do you think that there's going to be a relationship between cylinder and miles per gallon? Do you think more cylinders means more miles per gallon, or do you think that there's not going to be a relationship? Or do you think there's more cylinders means less miles per gallon? Think for a moment. I'll give you about 5 seconds. Okay, so let's run it. And here we go. Notice that as you add cylinders, as you go from 4 cylinders to 8 cylinders, the miles per gallon goes down because the car becomes more powerful and less efficient. So let's use ggplot2. This is a visualization library. And we're just going to now plot miles per gallon. By the way, you should always add titles, and you should always add axis titles and general titles. Here we're making it color blue. We're plotting data equals empty cars. You start with data, and then you have your stat, which is the variables you're plotting against each other. Here we're plotting weight against miles per gallon. X is weight. X is our independent variable. Y is our dependent variable. So what do you think is going to happen? What do you think this is going to look like? I think everyone's going to be surprised that there's going to be a negative correlation between weight and miles per gallon. So right there, it goes down. As cars become larger, they become less efficient. Now, let's see if we run a linear regression as MPG as a function of weight and HP. As a summary, here we have that both are significant. These 3 dots mean significance. Also, this t-value creates this p-value. The p-value less than 0.05 indicates significance under most definitions. Here you have an r squared. Here you have a multiple r squared of 0.8268, which is means that there is, in terms of the sum of squared residuals over the sum of squared errors, that means that the sum of squared residuals is small compared to the sum of squared errors, and you're explaining 82% of the data. You're creating a reasonably good fit. Just r squared is a little bit lower because that adjusts for the number of variables. There are 2 variables. If there was 1 variable, just r squared would be the same. And then the p-value is very low, which is created by this S statistic. And that means that the regression is very unlikely to happen by chance. But just to reiterate, there's a negative relationship between weight and miles per gallon. Heavier cars have lower miles per gallon. And same thing with HP. So what if I don't know what HP is? So help MT cars. And so we'll move on from this. But anyways, now we're going to plot, we're going to add the regression line to the plot from earlier. and look at that. So now, as we said earlier, there's a negative correlation, and we find that negative correlation with this beautiful little regression plot. And now we're gonna finish off with a dynamic visualization in Plotly. So this allows you. Plotly is a very powerful tool. It allows you to create interactive plots, and it allows you to create dashboards, which I think a lot of people find, particularly in business and management, find very useful. Dashboards and interactive plots are very useful for people who like to interact with data on their own, but aren't necessarily as technically proficient. So here we're going to create it, and look at this. We can look at all the data points. We can see these things. We can zoom in on a particular segment of the data, and we can zoom back out, and then we can just interact with the plot, and you can create more and more complex interactions. And then you can build with our Shiny different displays of these interactions you can post online and also look very good. If you're interested in that, I'm more than happy to talk about that. I think it's a very useful skill to have. I think it makes you much more employable. Now we're going to do the same thing with a 3D scatter plot with Plotly. So notice you can see how 3 different variables are related. You can rotate it around, move it around in 3D space. And then we're going to wrap up, and we're going to save the coefficients for future use. Here are the coefficients of the model. We're going to save them for use, creating predictions and whatnot. If you want to create a prediction, the variable is predict, and then if you go over here, you get to see the definition, you get to see the explanation. Let's go to empty cars. All right, here we go. Yeah, never mind. Anyways, but yeah, so so that's a very brief, very quick and painless, hopefully painless introduction to R. I tried to go relatively slow, and if you need any help on your homework, I am here. I hope you have a great day, and thank you.